Identifying end behavior of polynomial functions. Knowing the degree of a polynomial function is useful in helping us predict its end behavior. To determine its end behavior, look at the leading term of the polynomial function. Because the power of the leading term is the highest, that term will grow significantly faster than the other terms as x gets very large or very small. So its behavior will dominate the graph. For any polynomial, the end behavior of the polynomial will match the end behavior of the power function consisting of the leading term. So if we take a look at our graph here, okay, we have our first polynomial function. So we need to look at the leading term. So here is our leading term. So our leading term is 5x to the fourth. Now we need to look at the constant. Well, the constant, 5, is greater than 0, and the degree is even. Whenever that is the scenario, we have a rise on the left and a rise on the right. And then where we can write that as an end behavior, we can just write two arrows. The first arrow represents the left side of the graph, and then the right arrow represents the right side of the graph. Now let's also keep in mind that as x is approaching negative infinity, we see that the graph is approaching positive infinity on the left side. And then on the right side, as x is approaching positive infinity, we can see that the graph, again, is approaching positive infinity. So the end behavior on both sides of the graph are both with arrows up. Okay, let's take a look at the next function. The next function, we have a leading term of negative 2x to the 6th power. So if we look at the leading coefficient, negative 2, we can see that that number is less than 0. And then we have an even exponent. So in that scenario, it's even, but the negative value then flips the graph, which means it's going down on the left side of the graph, which means it's falling on the left, and it's also falling on the right. So the end behavior is two arrows, one on the left going down and one on the right going down. And then again, remember that if we wanted to go through this so that as x is approaching negative infinity, again, we can see that the function is approaching negative infinity. And as the x values are approaching positive infinity, then we can see that the function is approaching negative infinity. But again, here is our writing our end behavior. Falling on the left and falling on the right. Okay, let's take a look at the next function. So the next function has a leading coefficient of 3x to the 5th. So again, that's what we're going to use to determine the end behavior. Now, the leading coefficient is 3, so we know it's going to be greater than 0. And the degree is odd. So here is our function. We can see that it's falling on the left and it's rising on the right side. So that means it's falling on the left and then rising on the right. And again, if we go through our definition, as we can see here, as x approaches negative infinity, the function is going towards negative infinity. And as x is approaching positive infinity on the right, then the function is also approaching positive infinity. Okay, last one. We can see that the leading term is negative 6x cubed. So let's go ahead and analyze that. We know that the leading coefficient is negative. So negative 6 is less than 0. And we know that the degree is going to be odd. So in this scenario, it's going to rise on the left and then fall on the right. So here, as x approaches negative infinity, we can see that our function is approaching positive infinity. And as x is approaching positive infinity, then our function is approaching negative infinity. So here are your 4 scenarios of our functions. So again, just to review this, if our leading coefficient is positive and we have an even degree, then it's going to rise on the left and rise on the right. Okay, so let's go ahead, we can say that, rise on the left and rise on the right. Okay, now if we end up getting a negative leading coefficient with an even degree, well, what's going to happen is it's going to fall on the left and also fall on the right. If we go to this scenario, if we have a leading coefficient that is positive, but the degree is odd, that's going to mean that it's going to fall on the left and rise on the right. And if we take a look at the last scenario, if our leading coefficient is negative and we have an odd degree, then we're going to say that it rises on the on the left, excuse me, and it falls on the right.